This is a video on some basic definitions for probability, including union, intersection, and complements. So I have three sets defined above. Set A is 1, 3, 5, 7, and 9. Set B is 1, 2, 3, 4, 5. And set C is 6, 7, 8, 9. There's no other values. This is the entire set of all numbers. There's nothing outside of these three sets. So let's talk about some basics here. When we're talking about union, we're talking about this symbol right here. It looks like a uppercase U in between two sets. So set A union set B would be read A union B. Intersection is A upside down U, B, so it's A intersect B. And complement is A with an apostrophe on it, so it's A complement. Now the meaning of each is as follows. So A union B is anything in set A or B. So if you look at our sets, we have set A is 1, 3, 5, 7, 9. Set B is 1, 2, 3, 4, 5. So as long as it occurs once in either of those sets, it counts as part of A union B. So that result would be A union B is 1, 2, 3, 4, 5, 7, 9. Because all of these numbers and those two are all of the numbers that occur. We don't have to list off the 1, 3, and the 5 twice. A intersect B is anything in A and B. It has to be in both. So looking at this, I know there's a 1, a 3, and a 5 in both sets. That would be the result. 1, 3, 5 is the set of A intersect B. And A complement is everything not in A. So if A is 1, 3, 5, 7, 9, the values that are in set B that are not in set A would be 2 and 4. And then we also have to include all other sets. So 6, 7, 8, 9 have to come into play. But guess what? 7 and 9 are in there, which leaves us 6 and 8. So the last two to add to that would be 6 and 8. So the numbers that are not in A are 2, 4, 6, and 8. And that would be A complement. Let's try it for one more set, or one more problem set. So using these three sets, if we had D is 1, 2, 3, 4, 5, E is 6, 7, 8, 9, 10, and F is 2, 6, 10, 14, 18. Let's start with finding D intersect E. So what values are in both D and E? And if you look at those two sets, I don't see any numbers in common. So how do we represent an intersection that is empty? So we can actually just write, oh, that's a terrible parenthesis. Still terrible. You could write it as a blank set of parentheses, or you can put, it's like a 0 with a vertical slash through it. It's called the empty set or the null set. Okay, you could also just say null. How about D union E? So anything in D or E. Well, since there's no overlap, we're literally just going to be able to write all of the numbers in order. So that set would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Has to be anything in D or E. F complement. Here's F. So as long as it's in F, I can't write it. 1 is not in F, so I'll write 1. 2 is. 3 is not. 4 isn't, so I'll put 4. 5 isn't. 6 is. 7 is not. I'm going to carry this down to the next line. 8 is not. 9 is not, 10 is. So we'd stop there. F complement all of those numbers. What about this? We have D intersect E intersect F. Well, not going to be very exciting for this one because we already know that there's no intersection between these two. So not really the best example. This is also going to be null. Okay. In this case, we're looking for anything that's in all three problem sets. Now, if I were to adjust one of these problems or one of these sets, I'm going to make this really obviously different here. I'm adding the number 10 into set A. All of a sudden, since this would now have an overlap, 10 would be the overlap here. Doesn't change the union because it's already part of set E. Doesn't change F complement, but now all of a sudden 10 is common to all